Hello students, today we study about converse, inverse, contrapositive, tautology and fallacy. If a compound statement, if a statement is in the form P implies Q, if a statement is in conditional form, that is P implies Q, then its converse is Q implies P, and inverse is negation P implies negation Q, and contrapositive is negation Q implies negation P. If a statement is in conditional form, that implies if P then Q or P implies Q, then converse is Q implies P. Inverse is negation P implies negation Q, and contrapositive is negation Q implies negation P. When you find the converse, inverse and contrapositive, the statement must be in conditional form. If the statement is not in conditional form, first we convert the statement in conditional form. Then we write its converse, inverse and contrapositive. Let an example. Suppose it is given that a statement is given that if 2x minus 4 is equal to 0, then x is equal to 2. And the question statement is given that if 2x minus 4 is equal to 0, then x is equal to 2. Now the given statement is in conditional form, that p is equal to 2x minus 4 is equal to 0 and q is x is equal to 2. If P then Q, that it is in conditional form. Now write its converse. So its converse is P implies Q, converse of P implies Q is Q implies P. So the converse is if x is equal to 2, then 2x minus 4 is equal to 0. And the converse of the given statement is if x is equal to 2, then 2x minus 4 is equal to 0. And inverse is the inverse of P implies Q is negation P implies negation Q. That means 2x minus 4 is not equal to 0. If 2x minus 4 is not equal to 0, then x is not equal to 2. Now write the statement in conditional form. Then we write converse, inverse, and its contrapositive is if x is not equal to 2, then 2x minus 4 is not equal to 0. In this way you find the converse, inverse and contrapositive of a statement if it is in conditional form. Hence we must remember that if a statement is in conditional form, that statement in the form of P implies Q, then we write its converse. That is Q implies P. We write it inverse. That is negation P implies negation Q. We also write its contrapositive. Negation Q implies negation P. So converse, inverse and contrapositive of a statement is obtained if the statement is in conditional form. Let's take another example, that the statement is given that if ABC is a triangle, statement is given that if ABC is a triangle, then sum of angles is 180 degree. If ABC is a triangle, then sum of angles is 180 degree. ABC is a triangle is P, sum of angles of a triangle is 180 degree. It is Q. Now it is in the form if P then Q. So the statement is in conditional form. Now the converse of the given statement. Converse of P implies Q is Q implies P. That is, if sum of angles of a triangle is 180 degree, then the triangle is then it is a triangle. If sum of angles of a triangle is 180 degree, if sum of angles is 180 degree, then it is a triangle. And inverse of P implies Q is negation P implies negation Q. That is, if sum of angles is not 180 degree, then ABC is not a triangle. Inverse of P implies Q is negation P implies negation Q. Inverse of P implies Q is negation P implies negation Q. That is, if ABC is not a triangle, then sum of angles is not 180 degree. And contrapositive is, if sum of angles is not 180 degree, then ABC is not a triangle. So in this way we find the converse, inverse and contrapositive of a statement. First we have to see that the statement is in conditional form or not. If the statement is not conditional form, so we write first in conditional form. If the statement is in conditional form, then we write its converse, that is Q implies P. We write its inverse, negation P implies negation Q. We write its contrapositive, negation Q implies negation P. In this way we find the converse, inverse, contrapositive of a statement when the statement is in conditional form. If the statement is not in conditional form, then first we convert the statement is in conditional form. Then write converse, inverse, contrapositive. Now again we study about the tautology and fallacy. What is tautology? Tautology, T-A-U-T-O-L-O-G-Y, tautology. If a compound statement is always true, irrespective of truth values of the prime component, irrespective of truth values of a prime components, if a compound statement is always true, then it is called tautology. If a compound statement is always false, irrespective of truth value of prime components, then it is called contradiction or fallacy. Contradiction or fallacy. If a compound statement is always true, then it is called tautology. If a compound statement is always false, then it is called fallacy. So a compound statement is called tautology or fallacy if the truth values of the compound statement in all conditions is true, and the compound statement is false in all conditions, then it is called fallacy. Now take an example. Suppose question is given that constructing truth table prove that negation P or Q is equivalent to negation P and negation Q. By constructing truth table, we prove that negation of P or Q equivalent to negation P and negation Q. Now take a statement P, another statement Q, negation P, negation Q, P or Q, negation of P or Q, and negation P and negation Q. Now we take the prime components, that is P and Q. The truth values of P and Q are true true, true false, false true, false false. If a statement have two values, either true or false, then two statements have four values. Both are true, or one is true, other is false, or first is false, second is true, or both are false. These are the options. These are the options of the two statements. And negation takes its opposite truth value. If it is true, negation is false, false, true, true. Negation Q, true means false, true, false, true. When you find the negation of P, disjunction Q, P or Q, P disjunction Q, if at least one is true, then it is true, otherwise it is false. The truth value of P or Q is true if at least one of two, that is true, 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 false. And the negation of P or Q is false, 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 true. And the truth value of P, disjunction, negation P, disjunction, negation Q. The truth value of P, negation P, disjunction, negation Q. In case of disjunction, we know the truth value of P disjunction Q is true if both are true, otherwise it is false. Here negation P and negation Q, if both are true, it is true, otherwise false. Otherwise false. Now we see the truth value of column 1, 2, 3, 4, 5, 6, 7. Column 6 and column 7 have same truth values. Same truth values. So negation of P or Q is equivalent to negation P and negation Q. Two compound statements are logically equivalent. Two compound statements are logically equivalent if they possess same truth value. Here we see that these are two compound statements and they possess same truth values. Hence, logically they are equivalent. Now, column 6 and column 7 possess identical truth values or same truth values, so they are equivalent. Suppose question is given that find the truth values of negation P or Q, double implies negation P and negation Q. Then we form another column that representing negation P or Q, double implies negation P and negation Q. Here we see that in case of P biconditional or P biconditional Q, if both are same truth value, it is true, otherwise false. As they are same truth value, so it is true. Now we observe that the statement is always true. As the compound statement is always true, so it is example of tautology. And we take irrespective truth values of the prime components. We take irrespective of truth values of prime components. True, 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 false, false, true, false, false. That is irrespective. But we have the truth value of the compound statement is always true. When the truth value of a compound statement is always true, then it is called tautology. If always false, then it is called fallacy. And if it is neither tautology nor fallacy, it is called contingency. Hence, we know that if a compound statement is always true, then it is called tautology. So it is also an example of a tautology, as the compound statement is always true. Now let us prove some problems by constructing the truth table. We prove some problems. Now a question is given that by constructing truth table, prove that P is equivalent to negation of negation P. Here we take only one statement P, then negation of P, negation of negation P. A statement of two values, true or false. Negation is false, true. And negation of negation P, true, false. And here we observe column 1 and column 3 have same truth values. So P is equivalent to negation of negation P. Now, when we construct the truth table, we have to see that how the prime components are there, either 1 or 2 or 3. According to the prime components, and we construct the table. Let us see another example that question is given constructing truth table. Prove that P or Q and R is equivalent to P or Q and P or R. Here we see that is the three prime components. One is P, other is Q, and other is R. So we take three prime components. Next, the compound statement Q and R, P or Q, and P or R. Again, P or Q and R, and P or Q and P or R. And according to the question, we construct a table by taking the prime components. A statement have two values, two statement have four values, and three statement have 8 values. So now write the truth values of the three statements, that is true, 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 true. Write 4 truths and 4 false. 1, 2, 3, 4. We write 4 T's and 4 false. Then we write true, 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 false, false, true, false, false, true, 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 false, false, true, false, false. Now we write all the statements, all the truth values of the statement P, Q, R. Then we find the truth values of A disjunction, Q disjunction R. In case of disjunction, if both are true, it is true, otherwise false. So it is Q R, true, false, 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 true, false, false, false. Again P or Q. In case of or, if at least one is true, it is true, otherwise it is false. Hence we write true, 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 false, false. P or R, P or R, true, 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 false, true, false. And P or Q and R. In case of or, at least one is true, it is true, otherwise it is false. So true, 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 and false, false, false. False, 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 true, 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 true. Again we proceed that P or Q and P or R. In case of and, if both are true, it is true, otherwise false. That is true, 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 false, false, false. Now see that column, we mark the columns, that is 1, 2, 3, 4, 5, 6, 7, 8. Column 6 and column 7. Column 6 and column 7 possess same truth values. As column 6, column 7 and column 8. Column 7 and column 8 have same truth values, identical truth values. So both statements are logically equivalent. So this statement is equivalent to this statement. So when we prove by constructing truth table, we have to see the number of prime components and the compound statement. According to the question, we first construct a table, then we prove by constructing truth table. When the both statements possess same truth values, they are logically equivalent. If they do not possess same truth value, so they are not logically equivalent. Now today we study converse, inverse, contrapositive and tautology and fallacy. If a compound statement is always false, then it is called fallacy. And next class we study about the proof of a statement by method of induction. Thanks.